Hi everyone, welcome to another maths video by Maths with Sarah. So today we're going to tackle this question, which I think for a lot of people is just going to go, whoa, going to struggle with that one. So let's have a look at what we need to do to prove algebraically that 2.75 recurring converts to the fraction 124 over 45. Now this is not particularly nice looking for a decimal, and this is pretty not very nice looking for a fraction. So it's going to be an interesting one. Right, so this question comes from, it's pretty much the last paper on a paper 2, so you are allowed to use a calculator, but it's been asked you to prove it algebraically. So unfortunately, calculator is not necessarily going to help you too much. It's from the GCSE paper. It's probably looking at the grade 8, grade 9 question, but you know, anyone can give it a go. So I would encourage you to pause the video around about now, have a think about the methods that you might use, see if you can give the actual whole question a go. If you can get the answer, then perfect. If you're struggling with it, then check back in a second and I will go through the whole thing. So let's get started. So this question, we've been asked to prove algebraically that 2.75555555 continuing and never ending converts to this fraction. So how do we go about doing that? Well, the easiest way of doing it is to say that we have 2.75 recurring, and that is equal to x. So we say this is x. And then from there, we can go ahead and work. I am actually going to put a few fives on here just because I think it kind of demonstrates exactly what we're doing a little bit more visually. So then what we can do is we can say that, well, 10x is just this times by 10. So if we times this by 10, we're going to end up with 27.555 recurring. So again, I put three fives, and then we've got the dot. So hopefully you can see where we're going with this now, is that now if we subtract one from the other, we're going to essentially get rid of that horrible recurring bit. So if we now work out what 9x is, i.e. 10x subtract 1x, we're going to end up doing 27.555 recurring, subtract 2.755 recurring. Okay. So if we do this math, we're going to end up with 5 subtract 5, which is 0, and obviously every number after this is going to be a 5, so all of those would also be 0. So we've essentially kind of got rid of that horrible recurring bit. We're going to do 5 times 7, can't do that, we'll borrow one from here, that's going to give us 8. And then we're going to end up with 6 over 2, which is 4, 2 over 2 is nothing, which is 2. So we know that 9x is equal to 24.8. So now, if we work out what x is, so we know that x is equal to, i.e. this 9x is 24.8, so therefore x is equal to, let me just write this out so it makes it a little bit clearer. So we've got 9x equals 24.8. Now, if we just divide both sides by 9, we end up with 24.8 over 9. Now, looking at this, obviously it's got a decimal on top of a fraction, like that doesn't quite look right as any sort of fraction. So the first thing I'm going to do is multiply them both by 10 just to get rid of the decimal that we've got on top. So that's going to give us 248 over 90. And then remember, this is the fraction that we're aiming for. So we can simplify this down. We can divide both top and bottom by 2. Obviously, you could do this in one step. You could just times by 5, but just to kind of visually see how you might work through it. So if we halve both numbers, we halve 248, we end up with 124. And then if we do half of 90, then we end up with 45. And excellent. We have, in fact, ended up with a fraction that we've been asked to convert the recurring decimal into. So perfect. We know that we've got the right answer, and that's why these questions are really nice, because if you had made a mistake somewhere, it would have all come out at the end and you could have hopefully gone back and realised where you've made the mistake. So the important bits with this question is remembering to put this equal, set the recurring decimal equal to x, working out 10x, then using the 10x and the x to work out what 9x is, and then using that 9x to then figure out what the fraction is essentially. So in this case, 24.8 over 9, which you can then turn into like a proper allowed fraction. So obviously this is tricky, and it's one of the, what I would say, it's one of the few steps in maths where you actually kind of have to remember what the method is to work it out. So yeah, it's x, 10x, 9x, and then go back to working out what the x is. Obviously, again, there's quite a few steps. There is quite a lot to remember. And again, this changes if you've got a recurring decimal where you've got two, then you might need to times it by 100 rather than 10, or even 1,000 if you've got three portions, the three numbers that are recurring. That really does start to get a little bit more complicated. So hopefully, I think this is a topic that a lot of people just kind of either forget about because it's such a small topic on the syllabus, or it just is a bit confusing because it's a little bit different. It's a little bit, just a bit unusual. So, but I really think it's a good thing to revise. And once you get the hang of it, I think it's actually something that's quite straightforward to do. So if this question does come up, it's normally worth like 3 or 4 marks. So definitely worth having a quick look at. Okay. Thank you very much for watching. Please like and subscribe for videos to get more videos coming out.